Alright, we are getting closer to the end. This is question 9, May 2015 IBSL Maths Time Zone 1 Paper 2. Company makes containers of yogurt. The volume is normally distributed with a mean of 260 and a standard deviation of 6. Without thinking, I am drawing a pretty average normal distribution curve. Control Z, make that look a little bit more vertical for you. That's 260. Just label there's my mean. Standard deviation equals 6. Now I've got an idea what I am looking at. A container which contains less than 250 mils of yogurt is underfilled. A container is chosen at random. Find the probability that it's underfilled. So what I'm looking at in the first one is, here is 250 mils. And I'm looking for the probability that a container is in that area. This won't be terribly hard. And we can just do our writing over here. So probability underfilled. And that'd be nice if you can give them a little indication of what you're doing. So normal, cumulative distribution, lower limit, upper limit, standard deviation and mean. We know all these things. 266, upper limit of 250 in this case. Lower limit at least 5 standard deviations away. 0 is well and truly more than that, and that's what it's going to default to, so I'm going to go with those. Let's get our calculator up. That's not what we wanted. Let's see. Let's just put it here for now. Hopefully my face isn't blocking out all of it, but at least you can see the screen. And away we go. So we want to go into menu. This is stats, distribution. This is a normal distribution. I want a normal cumulative distribution. Lower limit of 0, upper limit of 250. Standard deviation of 6 milliliters and a mean of 260. Don't need to save our result anyway. Let's just calculate that. 0.0477903. Wow. So probability underfilled. 0.0477903. Something like that. You can go back and check if you're really concerned. I've got enough there to go with approximately equal to, keep forgetting to do that, always remember when I've got a pen to do it, 3 significant figures, 0.0478. That would be the proportion, or the probability that a container is underfilled. On to question 2, or part B, sorry. The company decides that the probability of a container being underfilled should be reduced to 0.02. That'll be a good reduction. It decreases the standard deviation to sigma and leaves the mean unchanged. Find sigma. Find the new standard deviation. Now we've got a problem here because we can't very well, so this is going to be for part B. We could use trial and error to try and figure it out on your calculator, but it's going to be very hard to communicate that. You need 4 marks, and writing down an answer is not going to be good enough. What we do know, though, is how to use our standard normal distribution. Mean of 0, standard deviation equals 1, and we want this area to the left to be 0.02. From here, I can find a z-score. So I'm going to use my calculator to find that z-score right now. So here we go. We're going to exit out to a distribution. This is another normal distribution question. This time I know the area I want. The tail is to the left. The area is a mere 0.02. I could do it with this, but the standard deviation is changing, so we can't do that. We're going to have to find out what that number should be by just using a standard deviation of 1 and a mean of 0. So our standard normal distribution, our z-scores, we go ahead and calculate, and that's a z-score that's 2.0537 standard deviations below the mean. 2.05374 8, 9, so let's just make that a 5, and this was negative. I said that it was before. Apologies for that. Let's make it look a little bit nicer. Pen back. So it's a z-score of negative 2.05375. Negative 2.05375 is going to equal the 250. If they're below 250, they're underfilled, so that hasn't changed. Minus 260 divided by the standard deviation. Okay, I am going to multiply by the standard deviation and divide by negative 2.05375. So sigma is going to equal, there's negative 10 in the numerator. I'm multiplied by sigma, so it cancels on that side. When I divide by that, it cancels from the left, but it does appear on the right-hand side in the denominator, negative 2.05375. What is our new value of sigma? Let's go to our calculator and work it out. Now we'll go menu number 1, negative 10 divided by negative 2.05375. Oh, yeah, we've got it over there, 375. And we've got 4.86914. Let me just keep it there. 4.86914. So theta equals 4.86914. Again, these are all approximately equal to, so it's approximately equal to 4.87 millilitres. That should be the new standard deviation. All right, the company changes to the new standard deviation. So we've got 4.87, leaves the mean unchanged. A container is chosen for inspection. It passes inspection if its volume of yogurt is between 250 and 271. Find the probability that it passes inspection. So I'm going to work over here on the left. Here we have our new distribution. The mean is still 260. The standard deviation, the new standard deviation, 4.87. When you're entering it in on your calculator, still try and include the larger number there just for greater accuracy. Between 250, so here's 250. Now only got 2% smaller than that, that's good. And 271 is up here. 271. We want to find that area in there, so find the probability that it passes inspection. Alright, probability passes is equal to, I am going to do normal CD, cumulative distribution, lower limit, 250, upper limit, 271. Mean, I always do it the other way to the calculator, but that's okay. You'll cope. Mean at 260, standard deviation at 4.87. I'm going to put in 4.86914 just for greater accuracy. Just keep them happy. That's their new move, is to get you to do that. So we are back into stat mode. Distribution. Normal distribution. It's a cumulative distribution. The lower limit is 250. The upper limit, 271. Standard deviation, 4.86914. And our mean is still 260. Execute that. What are you thinking? What's it going to be? Before you even look at it, you should have a rough idea. Have a look back here. This is a symmetric distribution. We know that to the left of 250 is 2%. This is 270 would be the point corresponding to 260. So this is going to be less than 2%. Overall, we've got to be less than 4%. Are we definitely less than 4%? Let's have a look. 0.968, so less than 4% missing, greater than 96% included. Sounds pretty good to me. So the probability that it passes equals 0.968. Better get those other values. 062. 968, somewhere I'm going to find my little cursor. There it is, 062. Wish it showed that little yellow circle when I play it back. I wish it showed it while I was doing it. That would make it a lot easier. So that's approximately equal to 0.968. And we are done part C. Part 1 of part C. Part 2 of part C. Given that, great, conditional probability, we're already on it. We're here, given that, we're thinking conditional probability. The container is not underfilled, so it's not in this area there. Find the probability that it passes inspection. So what they're really asking for is the probability it passes, given that not underfilled. What have we got there? Well, the probability that it passes divided by the probability of it passing and not being underfilled. We've got 0.968 is the probability that it passes. Now we're only interested in the area of the graph that contains the containers that aren't underfilled. So rather than looking at the entire area under the curve, we're now only looking at 0.98 of the curve, aren't we? Now, again, because this is a calculation, I should be using the 0.62 there, just for greater accuracy. But the probability that it passes, given that it's not underfilled, remember this is the probability it passes and is not underfilled, which means just it passes, divided by the probability it's not underfilled, which was 0.98. So we go ahead and do that. Menu number 1, 0.968062 divided by 0.98. And we get 0.9878. I think, again, let's keep them happy. Go to the 6-digit, 987818. Probably could have just remembered that all at once. Doesn't matter. Which is 0.988. Alright, finally we're up to part D. A sample of 50 containers is chosen. You've heard a sample, you've heard a number, you are thinking binomial distribution. The number in this sample, this binomial sample, is 50, and the probability that they pass inspection. So passing, we're back to the 0.968062. That was the probability it passes. It doesn't say anything about given that for this one, so you go back to the original one there. Okay, find the probability that 48 or more pass. Probability 48 or more pass. That would be the same as 1 minus the probability of obtaining less than or equal to 47. How do I find this value? That's 1 minus, and here we've got binomial CD, binomial cumulative distribution. And let's go ahead and do that on our calculator, and then I'll know what to fill in. Give us a bit more room there, make sure you don't disappear. So binomial, so we're going to menu, number 2 for stat, distribution. This is a binomial distribution. It's a cumulative distribution because we want to know up to and including. I'm going to use variable because I haven't got a list and I don't want to make a list up to 50. That would be painful. Cumulative distribution. Okay, hang on. It's variable, yeah, I haven't got to that yet. So here we go. We have... that's not the number of trials, that's how many successes we want, up to and including 47 out of a possible 50. The probability for success is pretty high, so it's 0.988. So we're going to expel, wrong one, 0.968062. Remember, we're going back to the original one there, and all this scrolling around, had it disappear off my screen for a second. There we go, 0.968062. Let's execute that and see what we come up with. But before we do that, I'm going to write it down here so you've got it on your screen. Oh, and it disappeared. X was 47. Num trial was 50. P was 0.968062. So what was the actual calculation going to be? It was 1 minus, here we go, let's execute that one, 0.214109. Give him a little pen back, 0.214109. Rub that one out. This little, so hard to find. And what do we get? We get 0.785081. Probably should have used my calculator for that one, but that'll do. And then we simplify that off to 3 significant figures, 0.7858. There, 5881. See, I should have used my calculator for that one. That was silly. $785. Get rid of the eraser again. 785,891, which then rounds off to 0.786. I think it's getting late at night, but I check my calculator on that one. So I go menu number 1, subtract 0.2. Try again, 214109, 785,891, so 0.786. We are done. There you go. That was a whopping 16 marks. Took us about a mark a minute, that one, with a bit of explanation. You'll be a bit quicker in the exam. Make sure you go through it again. Do something similar. Find similar questions on MathsNet IB or something similar. Have another go. Hopefully that helps you out. All right, one to go for this paper. See you then.